Hi, and welcome to this video. In this video, we're going to be talking about ionic bonding, and hopefully you're already familiar with how it's between a cation and an anion, or plus or minus, and it's between metals and nonmetals. In this video specifically, I'm going to be introducing to you how to name these. So first, what you're going to do is, let's for example pick Na and Cl to be our examples. So you notice that Na has a 1 plus charge and Cl has a 1 minus charge, and you want them to have a neutral charge or a sum of charge 0. So this is pretty straightforward. 1 plus plus 1 minus is 0. So we don't need to do anything special here. It's just NaCl because they balance with the 1 plus and a 1 minus. How to convert this into, well, a more written out name? Well, for the cation, which is the first one in the element, so you always write the cation first, you just write the name. So that would be sodium. Pretty straightforward. For the chlorine or the anion, you don't say chlorine. You don't say sodium chlorine. You change this ending to make it end in "ide". So it's not chlorine, it's chloride. So you end in "ide" just to kind of show that it's an ionic bond or just a bond in general. So for example, let's say we have magnesium and chloride instead. Sorry, chlorine. Now you notice that this one's a 2 plus charge while this is a 1 minus charge. So you can't just say MgCl like we did last time. That doesn't work because this is a 2 plus and this is a 1 minus. So instead, just do some basic math here. How many 1 minuses do you need to balance the 2 plus? Well, you need 2. So that's you do what this is called a subscript, and this basically says that you need 2 of these chlorines in order to make the ionic bond. So here, the formula is MgCl2. But how do I convert this into a name? Well, because you're only balancing charges, you don't need to indicate whether or not this, like how many of one there is. So it would be the same principle, you just say magnesium chloride. And like I just said, you don't need to put like a 2 anywhere because when they're writing like Mg and Cl, they look at the periodic table, they're like, oh, this is a 2 plus, I need 2 of these. So the person converting from this to this will know the fact that you need 2 of these because it's an ionic bond. You notice that this is different with covalent bond, but we won't be talking about that in this video. Let's take another example. We have Ca and phosphorus, so calcium phosphorus. This one's a 2, this is a 3. So in order to balance them, you need 3 calciums because you have a 2 plus charge here times 3, that's 6. And you need 2 phosphorus because you have a 3 minus times 2, that's a 6 as well. So that'd be Ca3P2. And same naming principles, we have calcium phosphide. And in order to know where to convert it to an I, just whatever makes sense. Like for example, hydrogen, that's kind of a weird one. But it's whatever makes sense. So that would be, sorry, my bad, hydroxide. So whatever just flows in the tongue. So that's like the basics of ionic bonding. However, the thing is that sometimes you have something called a polyatomic ion. So let's say that you are bonding CaSO4. How in the world do I get from that to calcium sulfate. So this here is what we call a polyatomic ion. And with polyatomic ions, they are covalently bonded and they bond with calcium because these polyatomic ions have a charge. These polyatomic ions, you would have to memorize them and you have to memorize their names. So I'm just going to give some short tricks of memorizing these polyatomic ions before we get into just doing some practice with them. I would like to note that not all of these polyatomic ions will work with the tricks that I have, but hopefully most of them do. So first what I want you to do is I just want you to draw this outer kind of L shape here, or this backward L. And I want you to kind of do that 180, just tuck in another one right over here. And make sure they're kind of touching at sulfur here. And you might be wondering, why am I doing this? And the reason is because this first kind of line here, this is where O3 equals 8 and O2 equals 8. You'll see what I mean in a minute. This bottom part is where O3 equals 8 and O4 equals 8. So what I mean by that is if you go over to the names here, for example, let's take a look at nitrate. It ends with an 8, right? And it's in this column, so that means 8 has O3. O3, as you can see here. So 8 and 8, if it ends with 8 or 8, not I'd, 8. Please, like, just keep on to that when you're doing self-improvement. It catches a lot of people. This has oxygens in it. I does not. If we take another example, for example, the sulfate that we were looking at earlier, you can see that it's in the second one over here. 8 has O4 in this one. So that's kind of how you remember the 8s versus the 8s. This doesn't work for something like acetate. That doesn't work out with this trick, but a lot of other ones do. So how about these charges? Because you're also going to have to know the charges to see how many of polyatomic ion you need versus like a normal one in order to balance the charges. Well, it's kind of like just stepping stones. We have -3, -2, -1, and that correlates with boron, carbon, nitrogen. Then phosphate has -3, sulfur has -1, and chlorine has -3, -2, -1. So you kind of jump over 2. And then the rest of this kind of follows the same principle. And one thing to note is that 8 is always the bigger one than 8. So as you can see, it's always one less, if you didn't notice that before. And if you have something like prefixes like per and hypo, well, per means one more. So it's +1. And this would be with oxygens, and hypo means -1. So this would work for a majority of the polyatomic ions. So let's do some practice with them. So let's practice, for example, magnesium and sulfite. So as you can see, magnesium is a 2+, 1+, 2+, and sulfate's a 2-, so you just do Mg, and then you do SO3 3. And you don't need the parentheses when there's only one of the polyatomic ion. But for example, if you're taking something like aluminum, so if we do aluminum and sulfate, so instead of sulfite, let's do sulfate. Same charge. So we're going to have aluminum has a 3 plus charge, sulfate has a 2 minus charge. So you're going to need 2 aluminum and you're going to need 3 of the polyatomic ion. When you're converting it back, you just say aluminum sulfate. So you leave it in the 8 that it is because it's already like an 8-ite or an ide. You don't want to convert it to sulfide because that's completely different. Remember, sulfide is that S. Sulfate is the SO4. So that's kind of how you work with ionic bonding and polyatomic ions, and I hope this video was helpful. Bye!